Welcome back to this video tutorial. In this video we can discuss about the special IC, that is the 8254 or 8253 programmable interval timer. This 8254 is the modified form of 8253 IC. The Intel 8253 and 54 are programmable interval timers and are designed for microprocessor to perform timing and counting function using three 16-bit registers. Okay, and is designed by Intel. Each counter has two input pins and are named as clock input and gate input, and one output pin named as out pin. To operate as a counter, a 16-bit count is loaded into its associated count register. On accepting proper command from the processor, it begins to decrement the count value until it reaches 0. And whenever it reaches 0, it generates a pulse or an interrupt signal that can be used to interrupt the CPU operation. Okay, so this interval timer is used for performing counting operation. Usually it perform a countdown operation, and whenever it reaches 0, then it generates an interrupt, timer interrupt to the processor in order to indicate that the countdown operation is completed now. Okay, so this is the architecture diagram and the pin diagram for 8255. Here we have 6 different units, and here it is 3 different counters. 3 different similar counters, counter 0, counter 1 and counter 2. Each having 3 pins, clock and gate input and 1 output pin. Similarly, here also clock and gate input and output pin. Here also clock and gate input and 1 output pin. And in this side, left side, we have in 3 unit interfacing with the processor. The data bus buffer for transferring data between the processor with this counting unit. It can transfer a single byte of information at a time. And here it is the read or write logic, and this unit can receive command from the processor in order to control or start and stop the counting activities. And here we have this A0 and A1 address pin connected from the processor or receiving from the processor, which will be used for deciding which counter we want to choose for our countdown operation. And also here we have this chip selection pin, which is used for enabling and disabling this counter unit. And this is a special control word register part. By programming properly this control word register, we can select one among these counter for performing the operation, and we can decide the programming mode, and also we can decide or we can choose one particular counter for performing our countdown operation. Okay, we can discuss the functionality of each of these units separately. So before that, this is the pin description or pin diagram for this 8254. The first 8 pin indicate the data transfer pins. 8 pin for transferring 8 bit of information, D0 to D7. Next, 3 pin indicate the pin of our counter 0. These two, clock 0 indicate the clock input to counter 0, and this gate 0 indicate the gate input to counter 0, and here it is the output pin for counter 0, and this is the ground signal or ground pin. And here we have the 3 pins of counter 1, gate 1, out 1 and clock 1. Similarly, next 3 form the pin of counter 2, gate 2, out 2 and clock 2. And this one is this 2, A0 and A1. These 2 information used for selecting one among these counter for our counting operation, and also we can select this control word register for change the mode of operation. Okay, and this chip selection pin is used for enabling and disabling this counter unit, and this read and write pin is connected with the processor in order to receive read and write command from the processor, and this is the power supply pin. Okay, The data buffer unit has three basic functions like programming the modes of our interval timer unit and loading the counter register and reading the count values from the register. So our buffer unit data buffer can receive data from the processor and we can load the registers associated with this counter before starting the countdown operation. Also, we can read count value from this particular counter register and transfer the value to processing unit. Okay, so all these activities are through this data buffer unit. Next is the read-write logic. It includes total 5 signals: read signal, write signal, chip selection signal and A0, A1 address pins. Okay, and the peripheral IO mode, this read and write signals are connected with input output read and IO write signals respectively from the processor, and in the memory mapped IO mode, these are connected with memory read and memory write control signals. In IO mode of operation, read and write pin of our read-write logic is in connection with IO read and IO write signal from the processor, and in case of memory read and write operation or memory mapped operation, these signals are connected with memory read and memory write control signals. And this is the usage of this particular table shows the usage of our A0 and A1 address information. If both are 0, then that indicate we are going to use counter 0 for counting operation. If it is of the form 0, 1, then we are going to use counter 1 for our countdown operation. If it is 1, 0, then we are going to use counter 2 for our counting operation. And if 1, 1, that indicate we are going to update the status of our control word register. After changing the status of control word register, we can change or we can perform or we can decide the separate mode of operation of counters. Okay, so this is the usage of A0, A1 pin of read-write logic. Okay, so now we can consider the working of our control word register. By updating properly this control word register bits, we can decide whether to perform write operation, whether to perform read operation, or whether to select counter 0, counter 1, counter 2, etc. So now we can consider these are the important bit of information associated with this counter register. The register is accessed when lines A0 and A1 pin are at logic 1, which is clear from this table. If both are 1, then we are going to choose control word register for its updation. Okay, it is used to write command word which specify the counter to be used. Which counter? We have total 3 counters. So based on the value of the current control word register, we can specify which counter among the 3 is going to use for our countdown operation and whether to perform or read write operation. All these are decided from the status of our control word register. Okay, so first consider this information A1, A0, read, write and CS signal. If 0, 0, 1, 0, 0, from this it is clear that read signal is 1 and write signal is 0. Okay, and this read, write and chip selection pin all are active low signals. And here it is both 0, 0. From the previous table it is clear that if both are 0, then we are going to use which counter? Counter 0. And here we are going to perform write operation because here it is the value 0. Read is in disabled mode and write is in enabled mode. And here it is the value 0 means we are activated our chip because CS is an active low signal and become active only when its value equal to 0. Next row, here it is 0, 1. That means we are going to use counter 1. Which operation? Write operation. Okay. Before that we need to check the status of this CS pin, chip selection pin. Here if it is 0, then only the chip become active. Okay, so now if here the chip is active, now we can perform a write operation on counter 1 register. Okay, so next operation 1, 0 means going to use counter 2. And what operation? Here it indicate read is in disabled mode, write is in active mode. So going to perform a write operation over counter 2. and here the chip is in selected active mode. And here, what's the meaning? Here we are going to perform 1 1 AF0 and A1 both are 1. That indicate we are going to select our control word register, and which operation we are going to perform over this control word register. Here we are going to perform write operation over the control word register. Okay, next is same pattern repeating again with read is 0 and write equal to 1. That means write is in disabled mode and read is in active mode. Okay, so over counter 0 we are going to perform a read operation over counter 0. Here also the chips are an enabled mode. Okay, and 0 1 and see here the chip selection is also 0. That means the chip is in active mode selected, or chip is active, and here we are going to perform then the read operation over counter 1. And here also the chip is in active mode and going to perform read operation on counter 2. Okay, so next, what's the meaning? If both read and write signals are at active high state, here this read and write are active low signals with value 1 1 here. That means both are in inactive state. So whatever value comes over this A1 and A0, no need to perform any operation, because here the operation is not selected. Both are in disabled state. Okay, here also, what's the meaning of this last row? This indicate that the chip is not in active state. That means chip is not selected. So whatever value comes here for this read, write and A1 and A0, no need to perform any operation, because the chip is in disabled or chip is in inactive state here. Okay, so these are the information or the set of operation we need to perform based on the value of these set of pins. Okay, next is about the counters. We have 3 different counters. Each counter consists of a single 16-bit down counter, which can be operated in either binary or BCD. That means we can pass binary or BCD number for this counting operation. Its input and output is configured by the selection of mode stored in the control word register. Okay, so which type of input value we need to pass to the counter, which are selected based on the mode of operation set in the control word register. The programmer can read the content of any of the 3 counters without disturbing the actual counting process. Okay, so while performing the counting operation, the programmer can read the current status of counter without interference or without interfacing or changing or altering or stopping the counting operation. Okay, we have such 3 counters, each having a 16-bit register. Using the 16-bit register, we can store the count value, and after loading that count value, it will start decrementing one by one after another based on the clock pulse information, and whenever it reaches to 0, it stops the counting operation and generate a timer interrupt to the processor, indicating the counting operation is completed now. Okay, so these are the features associated with this 8253 and 8254. They are actually almost same, but having some minute similarities. Like in 8253, its operating frequency ranging from 0 to 26 megahertz, and for 8254, its operating frequency is ranging from 0 to 10 megahertz. Okay, and a special type command, readback command, is not available in 8253, but the readback command is available in 8254 interval timer unit. The readback command allows the user to check the count value, the current mode and current status of the counter in working. Okay, so this readback command is used for checking the count value and the current mode of operation of the counter and status of the counter which are in active state. Okay, this particular readback command is not available in 8253 but available in 825. And also, read and write of the same counter cannot be interleaved in 8253, and the read and write operation over the same counter can be interleaved in 8254. Read and write over the same counter register can be performed in an interleaved mode in 8254, but it is not possible in 8253. Okay, so these are the basic information regarding this 8253 or 8254 programmable interval timer. Okay, thank you.